Hey guys, Dr. Brown here with Kubo Math, and we're still on the series of where did that formula come from. And today we're trying to figure out the derivative of sine inverse x. We're told that it equals 1 over the square root of 1 minus x squared. And we use that all the time. But now that I'm retired, hey, I have a little time now to figure out where did that come from. So let's get after it. Okay, we're going to use the limit, excuse me, the limit is h approaches 0 of sine inverse of x plus h minus sine inverse of x all over h. Wow, what to do with that? How do we figure out, there's formulations with sine of x plus h, but not arcsine, and this is not 1 over sine, but arcsine x plus h. Well, why don't we do this? Why don't we say that we're going to let sine inverse x plus h equal a. Okay? Sine inverse of x, we're going to let that equal b. Now you'll notice here before we do that, if h will approach 0, sine inverse x minus sine inverse x gives me 0. So this in a sense is approaching 0. Okay, but also let's let h equal sine a minus sine b. Because if a is approaching b, the sine of a minus, well, if a approaches b, it'd be sine b minus sine b. So they would be approaching 0. So that would satisfy this condition. All right, let's rewrite that. So now we have the limit as h approaches 0 of a minus b over sine a minus sine b. Now what to do? Well, there is a formulation out there. I guess this will go back to the, where did they get that? And maybe that's a different video. But it says sine alpha minus sine beta equals 2 times cosine alpha plus beta over 2 times sine alpha minus beta over 2. So we're going to plug that formulation into here. So we would have a limit, and actually this should be a approaches b now. That's the limit of a approaches b because we've taken h out of there. So now the limit is a approaches b of a minus b replaced with sine alpha minus sine beta, if you will, 2 cosine a plus b over 2 times sine of a minus b over 2. Okay, I tell you what, let's do one more thing. Let's let a minus b over 2 t equals a minus b over 2. Let's make that adjustment. So if we have the limit is t approaches 0, which would imply that a is approaching b, we would have the limit is t approaches 0 of t times cosine of a plus b over 2 times sine t. Now this will approach 1 as t approaches 0. And that also implies a is approaching b. So if a is approaching b, I end up with t over sine t is 1. So I end up with 1 over cosine 2b. If a is approaching b, so I end up with 2b over 2. So it equals 1 over cosine b. Well, what was b? b was sine inverse of x. So it's 1 over cosine of sine inverse x. All right, let's go back to some of our trig thinking here. We had in the beginning, we had that if you have sine, let's say sine of alpha, and that equals x over 1. We would say sine inverse of x over 1 equals alpha. So if that's alpha, that's my angle, it's saying that sine of alpha was x over 1. 1 was implied here. Okay, so what does that mean from a cosine perspective? And by the way, the sine inverse of x over 1 is the angle itself. So we're saying that what's the cosine of alpha is what this is implying. Well, what is cosine of alpha? So if this is x over 1, hypotenuse is 1, we have 1 squared minus x squared. 1 squared is 1, so the square root of 1 minus x squared. So we have 1 over cosine of that alpha equals 1 over the square root of 1 minus x squared. And that's where that comes from. That's how they come up with that. Now, you can do the same thing through implicit differentiation, come up with the same answer. I just thought this one was a little bit more cool. Okay, so there we have it. That's where the derivative of sine inverse x is equal to 1 over square root of 1 minus x squared. Okay, why are we doing this? We're trying to build a better tomorrow, okay? And we're doing that through math. Hey, buy a kid a book. Get linked up with your local schools and help them with supplies that they need, okay? Let's help these kids. All right, that's all for now. We'll talk to you next time. Thanks.